Hi guys, welcome to yet another episode or a new week of programming with C++. Our objectives for this week are to give you a solid understanding of how to customize C++'s operators and how to build class hierarchies. You will learn what operator overloading is, how to define derived classes, and how these two concepts enable the powerful OOP principles of inheritance and polymorphism. We will ensure these concepts are clear with practical and able C++ codes. Okay, so as you can see on your screen, there's a sample code that I'll be elaborating, and so you need to follow closely. Okay, so let's start with operator overloading. In C++, operators like plus or minus work naturally with built-in types like int or double. But what if you want to add two custom vector objects or compare two date objects? By default, C++ doesn't know how to do that. Operator overloading allows you to define how existing operators behave for your own user-defined data types, such as classes and structs. It lets you add special functionalities to these operators, making your custom objects behave more intuitively, just like built-in types. The general syntax involves using the operator keyword followed by the symbol of the operator you want to overload. Let's see operator overloading in action with a point class. By default, you can't just say point p3 is equal to p1 plus p2. C++ doesn't know how to add these point objects. However, by defining the operator plus method within our points class, we tell C++ exactly how to perform addition for point objects. In this method, we add the x coordinate and y coordinate separately and return a new point object with the results. Similarly, we can overload um, the double equal to operator to define what it means for two point objects to be equal. Now in main, point P3 is equal to P1 plus P2 works just like adding integers. If P3 is equal to P4 performs a meaningful comparison. This makes our code much more intuitive and readable, allowing us to use familiar operators with our custom types. But then take note that while operator overloading is powerful, it has strict rules. There are several operators you cannot overload, including the ternary operator, the scope resolution operator, and the dot operator. These are fundamental to C++'s syntax and cannot be changed. You also cannot create a new operators. You also cannot create new operators. You can only overload existing ones. You cannot change the number of operands an operator takes. Example, plus always takes two operands. The default precedence and associativity of operators are also maintained. And finally, at least one of the operands in an overloaded operator must be a user-defined type, like your class or struct. You can't change how int or int works. Wha- How int plus int works. Operator overloading offers clear advantages. It leads to simplified syntax, making your code more intuitive and readable. It brings consistency, allowing your custom types to behave similarly to built-in types. This ultimately makes your code easier to understand. However, there are disadvantages. The biggest risk is potential misuse. If you overload an operator in a way that's not intuitive, example using plus to subtract, it can lead to confusing and hard to debug code. Overuse can also introduce complexity, and as we just discussed, it's limited because not all operators can be overloaded. So use operator overloading judiciously and always with clarity in mind. Now let's move to derived classes and the powerful concept of inheritance. Inheritance is a cornerstone of object-oriented programming that allows one class to reuse attributes and methods from another existing class. The existing class is called a base class or parent class. The new class that inherits from it is called the derived class or child class. The main purposes of inheritance are to promote code reuse, avoiding the need to write the same code multiple times, and to establish is a relationship. For example, a dog is an animal. So the dog class can inherit common animal behaviors like eat and sleep. The syntax involves a colon followed by an access specifier in the base class name. Let's see a classic example of inheritance here. We have a base class called animal with common behaviors like eat and sleep. Then we create a derived class called dog, which publicly inherits from animal. Notice in the code how the dog class has its own unique method, back, and its own attribute breed. But because it inherits from animal, a dog object like my dog can also directly call eat and sleep, even though those methods are defined in the animal class. This demonstrates the power of code reuse. The dog constructor also explicitly calls the animal constructor to initialize the inherited name and age members. This is a relationship means a dog is an animal and therefore possesses all the general animal characteristics and behaviors. When a derived class inherits from a base class, an access modifier like public, private, or protected is specified in the inheritance syntax. This modifier controls how the base class's members are seen or accessed within the derived class and by outside code. With public inheritance, public members of the base class remain public in the derived class and protected remain protected. This is the most common type, preserving the base class's interface. Okay. So with private inheritance, all public and protected members of the base class become private in the derived class. This means they are not directly accessible from outside the derived class. With protected inheritance, public and protected members of the base class become protected in the derived class. Crucially, private members of the base class are never directly accessible in derived classes, regardless of the inheritance type. Sorry. You can only access them through public or protected methods of the base class. This table summarizes how access levels change. Inheritance isn't just a single pattern. C++ supports several types of inheritance to model different real-world relationships. Single inheritance. This is the simplest, where one class inherits from just one base class, like our dog inheriting from animal. Multi-level inheritance. Here, a class inherits from a base class and then another class inherits from that derived class, forming a chain. For example, car inherits from vehicle and sports car inherits from car. Multiple inheritance. This is where a single derived class inherits from multiple base classes. For example, a flying car might inherit from both car and aircraft. Hierarchical inheritance. In this pattern, one base class has multiple derived classes. Think of vehicle as a base class with bike, and truck all inheriting from it. Hybrid inheritance. This is simply a combination of two or more of the other inheritance types. Each type of each type offers different ways to structure your class hierarchies, allowing for flexible and expressive designs. While inheritance is powerful, it's important to know its rules and limitations. Not everything from a base class is directly inherited or behaves the same way. Static members belong to the class itself, not to objects, so they are not inheritable in the traditional sense. Friend classes or functions are also not inheritable. Friendship is not passed down the hierarchy. Constructors and destructors are not inheritable. Derived class constructors are responsible for calling their base class constructors to initialize the inherited part of an object. As we discussed, private members of the base class are never directly accessible in derived classes. They can only be accessed through public or protected methods of the base class. Understanding these rules helps avoid common pitfalls in inheritance. So guys, thank you for staying with us. Um, I hope you've been able to follow, and I hope by now you have some solid understanding C++, and you can create some simple project for yourself, can solve some wonderful problems, and contribute your quota to the society. So, um, see you in our next set of videos. Okay, see you in our next set of videos, and in those videos, we'll be building more projects or we'll be getting more interactive. So, guys, get ready, subscribe to the channel, like, turn on your notification bell so that anytime you post a video, you'll be notified, and then you jump right on the video and then you watch. So, stay blessed. Bye bye.